Hello friends, this is Dr. Sangeeta Joshi. In the last video, we have understood how to create a symbol and we have done it for the half adder. Now let us start to construct the full adder using the half adder. So new schematic, I'll go to the components, and since I have uploaded, or maybe that my symbol is there in the my directory, so I have changed the directory. So this is the name which we had given for the symbol half adder sim. So I have taken one symbol. So this is the first and this is the second one. So two half adders we require for constructing a full adder, as well as we require one OR gate. Now I have to again change the directory because now I have to go to the symbol directory, the symbols. So OR gate is a 7432. So 717432 I am collecting. Now I have taken the one 7432. Now I have to make the connections. So this sum is to be, this is the half adder output sum, so which is given as an input to the second half adder. Then half adder carry is to be uh, given as one of the inputs to the this OR gate. Then second input to the OR gate is from the second carry. So these two carries are getting ORed, and this is your final sum. So that final sum is to be taken here. Suppose I am showing this final sum as a like this. Okay, so I am also taking one wire from this for the output. Okay, so this is my carry and this is my final full adder sum. Okay, so I'll also put the names up appropriately. So the symbol name is the HA1 here, instance name, and here the instance name is the HA2. So these are the two half adders. Okay. Now actually A and B are the nomenclatures actually. Here we are giving the first input of the half adder, second input. This is first input and second input. Now what I'll do, I'll take the connections. So wire here for the A input, here for the B input. And you know that full adder is nothing but there are three inputs. Two inputs from the bits to be, two bits to be added, and third bit that is to be added is the carry. So that is the carry bit. So this is our carry bit. Okay. So I can write here as a carry in also. Now what we have to do, we have to give the labels. So I'll now write here as A input, first input. I am not writing any port as such. So this is my A input. And what is this? This is the B input. Either you can copy the same and then you later you can change the names. So I have copied all the same, but now this is my B input. So these are the two inputs and this is actually the carry in. So this is actually the carry in. So that is my third input, carry in. So that is, or you can write C in also if you find it is too lengthy to write. So C in. So right, this is the C in. Now I have to give the stimulate. I mean, here also I have to do the outputs. So output is the sum output, and this is the output port. Output port, okay. So this is your sum. So I have written here sum, and here also I am writing the sum, but then later I'll change it to the carry. So that is also output. So there are two outputs and three inputs. Okay. So this is the carry output, this is some output of the full adder, and this is A input, B input, and then the previous carry. And this entire circuit is nothing but the full adder circuit. Okay. Now we have to give the voltage source. So what I'll do, I will make this slightly shift here. Okay. And now I'll add the component voltage. Okay. So now how many sources I will require? I'll require three sources. One for A, one for B, one for C. So what I'll do? I'll first do everything for the first source. So V1, and I'll put the ground to the negative. Then take a wire and extend it. Okay. Then now have a label. So this label is the same label I'll have to give. So I'm writing here the A. Okay. So this is my A input, and then I have to give some pulse because we are giving the series of inputs, a series of combinations. There are A, B, C, which that means there are 3-bit inputs. So there are 8 combinations actually. So rather than having the switches or putting it 0, 0, 0, 0, 0, 1, we can have a advanced, we can have a pulse here. So I can start from the high input 5 as a initial value, then uh, V on as a 0 value. Supposing I am taking this delay as a 0, T rise time as a 1 picosecond, T fall time as a 1 picosecond, T on is suppose 1 microsecond, and T period is the double of T on, that is a 2 microsecond. So this is I have defined the pulse. Okay. So you can right click and make this as a vertical, and you can reduce the font size to the 1.0. Okay. And now you can shift this, move this appropriately to here. Okay, so the first A input, everything I have defined. Now I am writing the label name A here as well as label name A here. That itself means that I have connected this point to this point. Now what I'll do, I'll edit and then I'll do the duplicate. So I'll duplicate this voltage source and I'll put it here. Okay, so that would be my B. Okay, so that would be my, now what changes I'll have to do for the B? I'll have to change the label name, that is the B. Now if I keep the same pulse here, A as well as B pulse, if I keep the same T on and period, then I will not be getting all the 8 combinations of the ABC, or A and B combinations I'll not be getting, because I'll have to change the period. So what period I am now taking for this? Rather than 1 microsecond and 2 microseconds, I'll be taking 2 microsecond and here the 4 microseconds. So time period I have doubled. So frequency I have half. Okay. Okay, now I'll duplicate this and I'll create a third one because I need a C input also. So supposing, and now I have taken third input. Okay, now I'll make here as a C. I'll make here as a C in. That let's say maybe what will I use? Okay. So they'll have to change 4 microsecond and 4 to 8 microseconds. So my final pulse and conductivity which I am considering in this simulation is the 8 microseconds. Okay. Now one more thing we'll have to do, since we have used the 7.4 series, we'll have to include that file. So edit, go to edit, then .op spice directives. So I'll have to tell the spice through the directives that I'm including this file. So dot include 74 hct dot lib, right? Dot lib. Okay. So this is the file I am including. What else is required? You can now you have stimulations you have given, you have logic diagram, input output, everything is done. Now what is remaining is the simulation period. So end simulation, edit simulation command. So maximum cycle is the 8 microseconds. So I am taking the stop time as a 8 microsecond. So you are doing the transient analysis for the 8 microsecond. So now everything is done. So we can save this file. I will save as FA using HA. Okay, enter. So now I'll run this. So this earlier, this we can maximize. What I'm getting is the run A, B, C, and I'm also taking some and theory. I think there is some issue in the Anthony, Venus, Mercury, A, B, C in this guy. Okay, so I have got all the five signals. Now you add plot plane because we need now five plots: A input, A input, B input, C input, and output two carry and sum. So we require five plot planes. So three, then four, and then this is the five. So what I'll do, A input I will take up. So this is my first pulse. B input I have taken here. C input I have taken here. So you can see here this period was 1 microsecond and this is the 2 microsecond. This is the 2 microsecond and 4 microseconds. This is the 4 microsecond and 8 microsecond. And this is the sum and this is the carry. Now you can see the results. This is the 0, A is 0, B is 0, C is 0, so sum is 0 and carry is also 0. In the second, one of the inputs to the adder is the 1. So this is 1. This is, you can also add a cursor. You can also attach a cursor. Suppose I am attaching a cursor. If I take this cursor, suppose here. So you can observe here, you can see here. So you can see the cursor and watch the signals. So this is 1, this is 0, and this is 0. So summation is 1 and output is carry is 0. Okay. So likewise you can observe here also. So 0, then 1, and then 0. So output is 1. So but here you will find that this is the 1, this is the 1. So sum is 0 and carry is 1 because third is also 0. So carry is 1. So carry is 1. So your all plots are okay. That means your results are okay. Now I would like to let you know that how to add the comments because you would like to have your name on your schematic and while submitting also you will have to do that. So you go to the edit and there you will find the text. So you can write here Sangeeta Joshi. Okay. Okay. And you can place wherever you want. And then what is this circuit that also you can write. So text full adder circuit using half adder symbol. Okay. So now this is the title. So once everything is ready, then you save your file. You have the schematic as well as the plots snapshots in your journal. Thank you.